Okay, hello, hello. Can you hear me? Let me know if you can hear the sound. Right. Okay. Hopefully the sound is okay. So, shall we start the live stream tutorial for today? Okay. So this is a live stream tutorial, a weekly series called as Houdini Algorithmic Live. This is a 155th episode, and the topic for today is creating pixel sorting effect using solver and Copernicus COP network, the new COP network from Houdini 20, I guess was it. Right. So the result that I'm going to have is something like this. So you provide an image, you provide some threshold where it should be sorting, creating a mask, and creating a directions and amount of randomness, and then you'll be kind of sorting in specific direction with specific amount of pixels in order with the brightness or any other criteria you provide. In this case, this is sorted, the pixels being sorted in this directions using brightness as a sorting criteria. And by increasing the amount of the randomness as well as the direction changes, you could control like how much noises you add, how much of a distance you could sort between the pixels and stuff. Okay, so this is I'm going to try, and you could also create some masking images so that to define which part will be sorted more compared to the other places. Okay. And the base algorithm that I'm going to use in terms of a pixel sorting, I am referencing to one of the tutorial I saw on Touch Designer, pixel sorting and Touch Designer, which uses a algorithm called odd even sort algorithm for sorting, which works. The algorithm itself is pretty simple, which works on real-time system like Touch Designer, and it could also work on Houdini as well, together with the solver. So I'm gonna try to implement this one inside a COP network using OpenCL specifically to modify the pixels. Now, is the sound okay? Not really sure. Okay. Well, hopefully it is. Let me know if you cannot hear it. I'll just check. Okay, so before getting into the actual implementation, I'll just briefly go through the algorithms for sorting the odd even sort, how that works. So basically you provide a range of pixels either in diagonal directions or horizontal or vertical directions. Let's say you have a horizontal directions pixels, and each one has some kind of value. This could be brightness, this could be a red value, and so on. let's say it's being integer, like 3, 1, something like this. And what you want to do in the end is to sort this out so that it will go from small to large or large to small, either way. And that's the main essence of the pixel sorting. You just sort the array of pixels in with the criteria. Could be a brightness, could be like anything that you could retrieve from those pixel information. And odd even sort is one of the algorithms to do that. There are a bunch of algorithms in order to sort the pixels, but this could be this method is easy to use in shader languages, also in OpenCL as well for multi-threaded system. Okay, so the role here is to take account of the frame, each frames. Let's say it starts from frame 1 and frame 2 and frame 3 and frame 4, and each frame you kind of a sort in a local location. In this case, you're going to just compare the neighboring 2 pixels. Maybe I should have another one here. So on each frames, you're going to just look into a neighboring pixels to whether you should switch or swap those pixels or not. And the rule here is, first of all, count up. You also need to have a index number for the pixels. In this case, could be an X informations, which starts from, let's say, 0. Okay. And this is the frame. And this is an ID. Okay. So, and you're going to decide which neighbor is going to be used for swapping. Either this could be a swapping informations, or either these could also be a swapping pairs. Okay, in order to decide, you're going to create some informations like this. Frame plus ID, and calculate the modulus informations. Okay, and if the value is equal to 0, then you're going to compare with the left hand side. If it's equal to 1, then you're going to compare with the right hand side. You're going to swap with the right hand side. Okay, so let's try placing these arrows to each of the pixels using these informations. So if the frame is 1 and ID is equal to 0, then this result will be right. So we get a right arrow here. And if it's equal to 1 for the ID, you're going to add 1 plus 1. So if you divide by 2 the amount of the modulus is equal to 0, so you got left. So you get arrow like these in the end, and these arrow indicates which pixels should be swapped with which one. In this case, the first pixels will be swapped with the right hand side, and the right hand side one will be swapped with the left hand side one. So this will be a pair, this will be a pair, and this will be a pair to compare the value. And next thing you do after you decide which pair will be chosen to do a swapping, you actually want to decide whether you really want to swap by comparing these numbers, which could be a brightness or could be any numbers. So let's say you want to go from small to large numbers. Then in that case, for the first pair, you could go from 1, 3. So swap these pairs so that the left-hand side will be lower, right-hand side will be having a bigger numbers. And for the second pair, you don't really need to swap it because it's already on that order. And third pair as well, you don't really need to swap it. So that's that's the result for the second frame. And for the second frame, you choose another pairs using this rules again. Now this time the frame has become 2, so if you do a 2 plus 0, then that will be 0. But if you divide it by 0, the remains will be 0. So in this case, you get left-hand side arrow, and you get our arrow like these. In this case, you're going to have a different types of pairs like these. Now since the first one and the last one has no pairs, so it doesn't need to, it cannot swap as anything, so it just remains as it is. The second one, if you compare with 3 and 2, it's obvious that it will be 2 and 3 after the result by ordering it, and 1 and 4 for the third pairs, and 2 for the third for the last pair, which doesn't have any pair, so it's not going to swap. So you're just going to continue doing this process over and over again, sorting out until it will be, every number will be sorted in from lower to larger numbers, and that will be done inside the solver using a feedback loop. So in the end, it will be looking like this: 1, 1, 2, 2, and 3, 4. So that's kind of a basic rules how the odd-even pixel order works, odd-even sorting works. That's what I'm going to use in order to do a pixel sortings for a inside a COPS network. So that's the main part of the algorithm, so let's get to it, shall we, from scratch. Right, so the amount of node that I'm going to use today is pretty small, since it's just work. I'm just going to work on inside a COP network, so hopefully it'll be simple enough. Let me just save this file to today's folder. Okay, so I'm gonna start by creating a geometry node. Inside, I'm going to create a COP node, COP network, and since I'm going to use a solver, I'm first going to prepare a initial image that I would like to do a sorting effect. So inside is first COP network that I'm going to name as init. I'm just going to create a file node to import some image, which could be this default image, or just choose whatever image you want, like these or these. I'll try with these landscape image. Okay, now next I am going to for the initial image, this is pretty much it, since this is the image that I want to prepare. Now it's preferable to kind of reduce the size of the image for testing, which also affects the amount of the process. So let's go back here to init and set the default resolution to something like 1024 or something. which will didn't reduce it. Do we get it? Do we get the reduced image? Nope. Okay, well, let's do a resample to resize this image to something that's feasible. So I'm going to create another constant, which as a default will give you 1024 by 1024, which I've set on the COP network. So I'm just gonna put it into size ref input. As a result, you get 1024 by 1024. Now you do have some alpha channels on the margins, so you might wanna get rid of it or make it black. So let's create another constant information, or maybe this could be it. I'm just gonna make this constant as a black image and combine these two images using something like over. So the background will be black and the forward will be this image, so that I have seems like I'm having some repeated image. Oh well, I'll just go with these. Or can I just say add? Is it gonna make any changes? No. That might be because this is RGB, but maybe I should make it RGBA. Nope. Well, I'm just gonna go with the over for now. I'm gonna maybe come back here to fix these margins. Okay. Or maybe I can just resize with the scale by using resample node. So base size, size input, solution scale. Let's try removing it. Wow. Well, I'll just go with squares. Why not? Okay. And I'm just gonna try hovering over it. Like this, and we'll come back later. This is not that important. This is just the base image that I want to prepare. Okay. Okay, next I'm going to prepare some masking image to decide which parts should be sorted using the solver. Okay, and to do that, you could just make everything as a candidate for sorting, but if you do that, everything will just looks messy. So what I would prefer to is to decide based on like the contrast informations or brightness informations or red or green or blue informations on these image to filter to decide which part should be used as a solver. I mean, used as a pixel sorted place. So as a second reference informations, I'm going to create another COP network to create a mask informations. First of all, I'm going to import the original image that I have created using not the file but SOP import. I'm going to import the image that I have just created, initial image, and then I'm going to convert this into a layer so that you can process with the other image processing infos. So geometry to layer. And since this is a RGBA, we're gonna set it to RGBA. Okay. Now, in order to make a mask, it will be a good idea to make it like grayscale image. So let's say I would like to get some brightness informations out of this image. What I would do, I will use a RGB to HSV. In this case, V value is similar to a brightness value. So I'm going to collect this V informations out of this RGB image. So first I'm going to convert the RGB into HSV, then split the channel into X, Y, and Z. And the third value, blue one, will be the value informations for this image, which should be a brightness information, which should be close to a brightness informations. So I'm going to get it as a, I'm gonna connect to a null image, null node. So this is the kind of brightness map that you're going to get. Now after this, you could also control some brightness, or you could control the levels using something like bright node to make it more brighter or more darker and so on. So in this case, I would like to use the wider area to be pixelized, I mean pixel sorted, the black area to be ignored. So in this case, the cloudy areas, the skies and some waters and these white areas will going to be used as a pixel sorted, and these mountain areas, the trees and houses on the shadows will be ignored. So let's just try with those values. We'll come back later. Okay. And so we are ready with the initial image as well as the mask image, and we'll be ready to do a pixel sorting using a solver. So I'm going to connect the one that I want to modify into a first image, first input, and the one that I want to use as a mask reference to a second input. Okay. Now we're going to have two informations. One is this updated image, which is going to be updated per frame. I'm gonna name it as call, and there's two references. One is the initial original image. I'm gonna call it as image, and from the second input you're going to have a mask. Okay, or I'm just going to call it init. So from the first input, the input one, you're just going to get the original image, which it's not going to be modified by a solver. Only the image coming from pref frame will going to be modified. Okay, so we have those three informations. Now let's create a COP network inside the solver as well. So again, creating COP network, and I'm gonna connect to the out. Okay, so inside the COP net, I'm going to again import the SOP node, which in this case I'm going to select the call, which is coming from the prev frame input node, which looks like this. Now first of all, let's test this out if the feedback loop will actually work with this setup. So we have a SOP network, SOP solver, we have a initial COP connected to a first input, and then we have this pref frame connected with the null node, and COP network input connected with the output. And inside the COP network, and I'm going to again import the subnetwork from a call, the named call, which is this one. Then what I want to do is to update this image. So first of all, I'm going to convert this to a layer, not this one. Geometry to layer. Okay, and this is RGBA, right? Now, the things that I want to do here is to, let's say, for testing, let's just try changing the hue value of this image using a solver to see if it's gonna work. So let's use HSV adjust to change the hue informations. Like, let's change by 10 for each frame, and go out of the network and see if it's going to work by playing the solver. So as you can see, for each frame the hue is changing by shifted by 10. So the setup itself for the cop together with the solver works like this. Okay, now instead of using HSP adjust, what we actually want is to sort the pixels. So to do that, I am going to use a OpenCL for that purpose. Okay, so let's do that. And to do that, we need additional informations, that is a mask information. So another sub import and choose a mask. And then also changes to a layer, geometry to layer. In this case, this is a single float, so it should be mono. That's correct. Okay. Now, well, now this is fine, I think. So let's try using these two informations for pixel sorting, shall we? So I'm going to use OpenCL for that purpose. Now for the first layer informations, I'm going to connect to a source. And for the mask, we need additional input here on OpenCL node, so let's add one. So let's go to a signature tab and let's add additional inputs here, adding 2. Let's call this mask and make it mono. And let's also define here as well, just like the source and destination value, to be float. Okay, also I might want to define the variable for source and destinations to be float for, just in case. Okay, the reason why we have error is because we haven't connected the mask yet. So let's connect it here. Okay. Okay, so we have the setup. Now we are ready to do some coding here. Okay, let's see. So first of all, let's try with the simple setup. Let's say we want to pixel sort on a vertical direction, or horizontal directions, maybe horizontal directions first, and later we're going to add some angles as well, either horizontal, vertical, or diagonal directions. It's a bit hard to do with the angle other than the multiplication of 45 degrees because of how pixel works with the neighbors. So as long as I'm using the odd even sort algorithms, it only works with the multiplication of 45 degrees. So if you want the other more small range of angles like 30 degrees or 15 degrees, you might need to go for other sorting algorithms. but at least this works for double multiplication of 45 degrees. So let's go with this for now. Okay, so first thing first, what I would need to do is to get the current point, the current pixel informations and the neighbor pixel informations, and you also need the frame informations as well, like with these algorithms, to decide which part you're going to compare with, either with the left hand side pixels, with the right hand side pixels, and so on. Okay. So to do that, so we do need additional informations frame. Okay, so let's get that information as well. To get that information on OpenCL, going to bindings, I'm going to add one additional variable, call this frame, and make it float, make it node, and the value, I'm just going to type an expression, the float frame value. I'm not going to use f, this is an integer value, but instead I'm going to use ff, the float value, because in the end I would like to also increase this substep as well. So in order to get the frame in floating numbers like 0.2 and 0.1 together with this substeps, you need to use ff expression for that purpose. So I'm gonna go with ff, but for now I'm going to just assume that the frame number is the multiplication of 1. I mean the addition, incrementation of 1 for now. I'm gonna go update it later. So the next step, so the current x value or x index of this current pixels that I'm looking at on the OpenCL is ix. Okay, which might be integer, so you might get errors. No, I didn't get any errors. Okay, and the y is ix, iy. Okay, now what you want to do next is to check the frame value. Let's bind the frame as well. So the float frame is at frame. Okay, now let's say you want to compare, you want to do the pixel sortings on x directions. So in that case, what you're going to do is to do these calculations, frame plus id, and in this case this is an x number. Okay, so going back, what you want to do is to check the frame plus x and possibly convert it into integer values, so making an integer, and then calculate the modulus with 2. Okay, and if this value is equal to 0, then you want to compare with the, let's say you want to compare with the right hand side. And was it? No, left hand side. So if this value is equal to 0, then you want to compare with the left hand side. So meaning the index of the pixel will be x minus 1. Okay, so let's say float nx. I'm gonna use n as a neighbor, so start with the original x. So nx in this case will be x minus 1. Okay, and y doesn't change because it's horizontal. Now else you're going to compare with the right hand side, so the neighboring will be nx is equal to x plus 1. I'm using float because it's easier for divisions and so on. Okay, sorry for the sounds of keyboards. It's a bit close to my keyboard. Does anyone else find it? Okay, thanks for all the comments. And what was I? So, next thing you want to do is to compare the pixels, right? So on the X part, the current pixels and the neighboring pixels. Okay, so to do that, you're going to need to sample the texture, which you need some functions on OpenCL, which you can see it from the page which says OpenCL for Vex users, which gives you a bunch of options to sample the pixel informations and so on using OpenCL in many contexts. Now what I'm gonna do, what I'm gonna use is either these two functions. Using a texture sample, we'll get interpolated, like smoothed value out of the image. The texture nearest will just find the closest pixels as it is and just get that information. Now I would prefer this one instead of using texture sample, because you don't want to interpolate any pixel image. You just want to swap between two pixels as it is by not changing any values at all. So in those purpose, I think this is better, texture nearest. It's more like a point filter sampling. So I'm going to use this one to sample the pixels on the next neighboring image, neighboring pixels. So I'm going to copy that, and the current pixel information is source. Okay, and so let's have that. Let's have it as col1, which is source. Now col2, which is going to be a neighbor color, will be retrieved by using this function source dot texture nearest xy. This is the UV informations to get the pixels. Now there might be some other functions which you can use ID instead, maybe. Let's see, there might be a functions like get. That might be easier, but yeah, get at. So by using this one, you could get the absolute pixel value by providing the index value. So you can use either get at or the texture nearest. Well, although this is for the field, so maybe this is not for the layers. I'm not sure if this can be used for layers, since this does not have any parameters for 2 x and y. Okay, well, instead of using this one, I'm just gonna use this one instead. So instead of using integers for this xy, you need to kind of normalize the value into 0 and 1 for x and y. So instead of using the value as it is, you need to convert it into a UV space for these informations. So let's do that. So neighbor UV which will be float 2, will be nx plus 0.5 to make it a middle of the pixel, and divided by xres or resx, I forgot, and need to have a parenthesis like this. Okay, and same for y, but y, in this case y does not change, so you can just use this y as it is. So y plus 0.5 divided by a y res. Okay, I'm getting an error, so something must be wrong. So, okay, forgot to use this one. So after you have created the neighboring value, enter it right here. Okay, so now that I have these two values right here, meaning for some pixels you're just getting the right pixels informations. For some pixels you're getting the left hand side pixels informations. Okay, and what you want to do next is to compare these two brightness, okay, or are red, blue, green color or anything. So what you want to do is to convert these flow 4 or flow 3 informations into a brightness informations. So let's try to grab some equations in order to convert the RGB informations to brightness. I'm just gonna copy paste some of the formulas found on the web. Okay, let's see. Relative luminance. So does it have some informations? Okay, so something like this. Y can be calculated for those. Okay, this is a bit. Let's just look for some code which I can use easily. Okay, so maybe this one. Slower to calculate luminance, perceived options. This is good enough, guess. So RGB is the normalized value, I guess. So I'm just going to use this equations here found on the Stack Overflow. Okay, so I'm gonna create the functions. Calculating like this. Okay, so this is a capital letter. Okay, so this should give you some brightness informations. So let's use this function to get the color brightness from color 1 and color 2. Brightness 1, source X, source Y, source Z. So X stands for the red, green and blue. Okay. Brightness 2. Just gonna copy these, and instead of maybe I can just say call 1. Either way is fine. But easier to see with the next one. Call 2, and call 2. Okay. Now hopefully I am getting the there is a comment from Edge. There is also a source buffer index. Good to know. Thank you very much. So I've got two brightness informations. Now it's time to do a comparisons. Okay, so if let's say this is the, let's say we're looking at the left hand side informations. So if the brightness 1 is larger than brightness 2, and if you want to go from lower brightness to the brighter brightness from left to right, then in this case that's fine. But if the brightness 1 is smaller than brightness 2, then you need to swap the location between col 1 and col 2. So let's do that. If brightness 1 is smaller than brightness 2, in this case you want to have a final color to be swapped to a neighboring color. So let's create a final color, just copying the source for now. And if this if this condition matches, then update the final color to color 2, or let's say color 1 here. Okay, now on the other hand, and I need additional conditions, which is this frame informations, I think. Yeah, I do need this informations as well for this conditions, in order to, because if the condition is if this value is 0, then this condition is okay, but if this condition is equal to 1, then you have to have the other conditions. You cannot swap it in that if that's the case. So let's get this informations again. You get this conditions again. Let's have this as a variable, shall we? I'm gonna call it as index check. Copy these value here like this. Okay, now I'm going to bring this conditions to here as well. So if the index check is equal to 0, then you're going to use this conditions as well. Else, if the index check is equal to 1, then in that case the comparison will be a different direction. You're going to compare with the right hand side. So if the brightness 1 is larger, then you want to swap it to a smaller one, because you're on the left hand side. Okay, so if this is the case, am I writing correctly with this? Final call is again a call 2. So maybe you can just say or here. Well, I'll just go with these. Okay, so no errors right now. So at this point, I haven't used mask information yet, but I could try if everything is going to try to be sorted. So on horizontal directions. So let's see. Going outside the solver and see if you can see anything. Nope. Nothing is changed. That is because I haven't set anything here. I have to set the final color here for the OpenCL. Alright. Let's go back and try playing it. Now something is happening and I think it is working. Let's look from the front view. I see a lot of moire effect, but I think it is sorting by a brightness. The reason why you see like a kind of a split info bit is it's actually how you see on this odd even sort functions or algorithms. So let's try to go a lot further, and you start to see those kind of merging or sorted. Everything start to be sorted. Now there are some conditions that I haven't set yet, some like constraints on the edge and the masking image. So first of all, I think I do need a constraint on the edge part. Specifically, if you're looking at this pixels and comparing with the one that's right next to it, and if there's no pixels available, then you should not do any like swapping for those pixels. Same for the left hand side. So let's add that conditions. So that could be added somewhere around here where you are actually doing a swapping. And to check whether the neighbor pixels is out of the original image, you could check this neighbor UV here. If the UV is within 0 to 1 for both X and Y, then it's within the original image, so that's good. If not, if it's less than 0 or more than 1, then that's outside the original image, so you don't want to do a swapping. So what you could do is to check if the X is more than 0 and neighboring UV dot X is less than 1 and neighbor UV dot Y is more than 0 and neighbor UV dot Y is less than 1. Okay, so this is some additional conditions you want to add. Okay, so let's see. So we're going to see more better result for the sorting, I think. Okay, yeah, in the end it looks like these. So horizontal directions has been sorted by the brightness. You are keeping every pixels, but you just replacing those pixels by brightness. That's what's happening here. So in this case, the left hand side have lower brightness, the right hand side have brighter brightness. Okay, so currently I'm using a substep of 1, but maybe since this is fast enough for now, so maybe I want to increase the substep to increase the calculation speed. But currently it doesn't work like that because I haven't considered about how much substep it's being used, because inside the solver I'm just using a frame as it is. But actually if you're going to use a substep informations, you kind of need to consider how much subsets you have together with the FF value, which is currently a float value. So inside the solver, with the substep equal to 5 in one frame, you are having five substep, meaning you're going to have 0.2 float frame, 0.4 float frame, 0.6 float frames, and so on. But those float frames are float value, which is not a multiplication or incrementation of 1, so it cannot be used with this calculation right here because it assumes that the frame is integers. So in order to be able to use those float informations to the frame, you just need to multiply this frame by a sub step. If it's 5, then multiply by 5, then every float frame will become integers, and then you can now use these with this method. Okay, so you need to bring this substep informations, copy it to a OpenCL as a variable. So I'm going to go binding again. I'm gonna name this substep, make it an integer, and paste this value that I've just copied, which is 5 currently. Okay, now going back to a kernel, I'm going to bind it. I mean, it's already binded, so you don't really need to enter here, I think, but just in case. Okay, now I have a substep. Now what I want to do is to multiply this frame by substep. Okay, so with this I should be able to speed up the calculations by increasing the substep. So this is step 5. This is step 1. So you see some speed difference. If I make it to 10, yeah, I think it becomes much faster than before. Okay, now if you increase the substeps, you would see some slow process because you're going to multiply the same process by 10, so maybe it's depends on your CPU. Okay, so I'm gonna go with the 5 for now. Okay, going back to the node, next thing that I want to do is to use this mask information that I have here. Okay, so it's pretty simple. You just need to add some conditionals again for the mask somewhere around here. Okay, so let's get the corresponding mask informations to the color, just like I did right here. So mask 1 is the original mask. Mask 2, I'm going to use the similar functions that I have here. So mask.texture nearest neighboring UV. Okay, so the rule here is to define a threshold for a mask. If the mask information is more than, let's say, more than 0.5 or more than threshold you specify, then use it as a candidate for swapping. If it's less than a threshold, something like 0.5, then ignore it. Those kind of conditions that I want to add. So let's do that. So I'm gonna add a conditions right here as an addition. So if the mask 1 is 0.5, more than 0.5, and the mask 2 is more than 0.5. Now these two masks must be same. I mean, in terms of the threshold. So these 0.5, the threshold value, should be the same for the mask 1 and mask 2 because you're referring to the neighbors. And if you're referring to one of the neighbors, like this one, then on the other process, if the neighbors for this left hand side pixels is this one, then the neighbors for this pixels is the left hand side one. So it makes sense to make the threshold for the mask to be same to be able to have the same conditionals. I mean, for left and right, to be able to actually swap the pixels without like losing those information somewhere. Okay, so should do it. Let's test this again. So if I play it, now only those part where you have a threshold brightness more than 0.5 will start to sort, which is pretty much a small part of the image. So let's let let's add some parameters. So let's add some bindings so that you can also control the threshold as well, which is this 0.5 informations. So going back to a bind, I'm going to call this thresh. The value, let's say 0.3, so it will be more sensitive with the brightness, and bind it. And use it here. Okay, let's see the result. If I play it, now still many parts are kept without pixelizing, pixel sorting. So let's also decrease. Wait a minute. No, to make it sensitive, it has to be bigger, I guess. So 0.7. 0.7 should be a big amount of pixels being sorted in this. Maybe not. Sorry. Maybe not. Sorry, yeah. 0.1. Okay, now a big amount of pixels has been sorted. The dark area is being preserved as it is, but those areas which has brightness values start to sort horizontally. Okay, start to look interesting. Okay, now so far so good. Next step. Currently it's only going horizontal directions, but actually I want to be able to control the angles. Could be vertical, could be diagonal, but as I said, it has to be the multiplication of 45 degrees as a limitation. That is because this algorithm is comparing with just the neighbors. So if you look at these pixels on the center, the options you only have with the neighbors is either horizontal, verticals, or diagonal. So these are the only candidate which you can swap with. I mean, that is the limitation of this algorithm itself, odd even sort with the pixels. I mean, if you could gather all the pixels in array beforehand, then you might be able to try with more angle value like 30 degrees or 5 degrees and so on, but for this specific algorithm that I'm using, it's only for diagonal, only for 45 degrees pitch angles. So that's one of the limitations, but still it looks fun. Let's go with it. Now going back to the comp network, going to a OpenCL, and let's write some code to get those angled pixel informations instead of just getting a x directional one. Okay, so first thing first, let's create a angle informations, and you probably might want to add another bindings for the angle. So let's create one. Let's call this angle. I'm just gonna call it as either float or integer. Not sure which is better. Maybe integer. Okay, integer. And since we only have, let's say 1 2 3 4 5 6 8 neighbors, we can just say the value in between 0 to 8, or we could just enter a angles like 90 degrees by yourself. But to make it sure that there is a limitation, maybe I'll just limit the value in between 0 to 7 and multiply it by 45 degrees inside the code. Okay, I think that will be better as a interface. Okay, so I'll go with the integer and bind it. Okay, and the actual angle that you want to use is angle integer value multiplied by 45 degrees divide by 180 degrees multiplied by pi. So pi is a pi, and pi is 80 degrees in degrees, so by calculating with this equations to 45 degrees you get a radians angle and multiplying by integer value. I think you could do 0 to 360 angles, then convert that to the closest. Yeah, you're right. If maybe that's better, maybe. Okay, then let's do that. So let's say the angle is 0 to 360 degrees, and you're going to divide it by 45 degrees, and is there a round functions for a OpenCL? Let's check. Just looking for a functions, whether if they're a round functions. Not sure. Let's just try it. Okay, seems to work. So this will be yeah, this should be between 0 to 8. Actually, this has 8 as well. So in the end, you might want to calculate the modulus by 7, because 8 is by 8. Sorry, not the 7, but 8. Okay, now I'm having an error because this is not an integer, I guess. No, actually, this has to be. Well, anyway, after I have make it a value in between 0 to 7 as an integer, I'm going to multiply by oops, didn't mean to delete it, multiply by 45 degrees and 100 degrees divided by pi. Okay, so this should give you value in radians in the end. Maybe there are some unnecessary calculations right here, but anyway. Okay, so after I have got the radians value, I'm going to get the x and y informations from this angle, so I'm going to use a cosine and sine for that. So direction x, cosine angle, direction y, sine angle. Okay, now so you're either looking at the horizontal directions or diagonal directions or vertical directions, so dx or dy should be either at 0 or 1. So I'm just going to make this 0 or 1 by checking its value by, let's say, but there's a chance that this is gonna be a negative value, right? So let's see, what will be the best way? So first of all, if this is okay, if I am going to get the absolute value of the cosine, and if it's more than 0.1, then just give you 1, if not 0. Although I do need to get the signs either negative or positive, so I'm going to use something like this. Okay, and I'm getting error. I'm not sure if okay, wait, at the end of the declaration sign, oops, have to be semicolon. Okay, so hopefully this is correct. So if the absolute value of the cosine, which is pretty much more than 1, I mean more than 0, you could say 0.01, then let's make it just 1, make it 1, or I don't know. I am not sure if this is, yeah, well, anyway, this is already truncated into, like, quantized to 45 degrees, so that it should be fine. Just make sure 0.1, and if that's so, just get either 1 or -1 with these calculations. If not, if it's close to 0, just 0. Okay, let's do the same thing for the sine function. Okay, so just combine it to sine, change it to sine. Okay, now you have a value, directional value for x and y, either 0, 1, or -1. Okay, now for the neighboring, what you want to do is to add this dx value instead of just to an x, but just to an x, but also apply to ny as well with dx or dy. So nx ny is equal to y minus dy. You can replace this with dx, or plus dx and y is equal to y plus dy. Okay, now you also need to do a check part corresponding with the x and y value as well. So how do we do that? Okay, so to do this, so let's see if it's x. I think I can just say, wait a minute, so substep is equal to x. So let me check what we need to have as an information. So so let's say this is an ID of 0, 1, 2 for x directions, 0, 1, 2 for the y direction. Okay, and if it's diagonal, you also need to have some information, whether 0, 1, 2 or something similar to it. Okay, so to be able to get those informations, what I can think of, I mean, maybe you can just, since this is just the diagonal information, you can use either x value or y value for the diagonals. And if it's just going into the vertical directions and use Y, horizontal directions use X, the diagonal directions use either X or Y, maybe just get the bigger one instead, bigger value instead as a total value by checking the resolution X and resolution Y, maybe. Yeah, so, or if that's okay, that's okay. Yeah, should be okay. Okay, so let's go with that strategy. So for this value, I'm going to name it as, let's say, offset or ID. Okay, now if the direction is X direction, in this case I can check that by getting the absolute value of dx comparing with the dy. If the dx absolute value is less than dy, then use create a ID value starting from 0 and use the y value, so like this. If not, ID ix. Okay, and hopefully that will just do the job, I think, even for a diagonal. So even for the diagonal pieces, the chance is that the condition will be equal. dx is equal to dy. The absolute value is equal. So in those cases, you gotta choose which ID to be used. But since this is a diagonal, I mean, whichever could be used, because the length of the x and y is the same. So yeah, maybe both of them. Okay, so let's go try with these. And we have this angle, the neighboring informations. And what else? We need to make this ny as a neighboring UV. And that's pretty much it, I guess. Isn't it? Okay, let's try. So, let's try changing this angle to 45 degrees first. See if it's gonna sort in diagonal directions, and yeah, I think it's working. Let's just check with all the other angles. 90 degrees. Huh? Why it's going this way? It's not supposed to go diagonal for 90 degrees. Maybe something is wrong. 180 degrees. Okay, something is wrong. Something is wrong. Maybe I'm doing something wrong here. If it's 90 degrees, it's supposed to go vertical. So if it's 0, it's supposed to go horizontal. Yeah, so this is fine. 0 going horizontal is fine. Okay, so 90 degrees is wrong, obviously. What about 135? When does it... Okay, let's create some null node so that I can control the parameters while I'm playing the solver. Okay, so I'm gonna add a angle value from 0 to 360 degrees. 360 degrees. Okay. Okay, copy this value. Go inside a cup and paste it here. See what's happening here. Let me also make sure, I mean, maybe this is better float in this case then. Okay, make it float. And go back to a binding part. I'm gonna make sure this is a float. Okay. Is this what's wrong here? So maybe instead of round I should have been using floor, maybe? I'm not sure. 45 degrees multiplied by 100 degrees divided by I'm not sure what's wrong here. Let's try this again. Okay, so while playing, I'm going to try to change this angle, see what's happening. So 0, 45 degrees, 90 degrees, 135 degrees. Okay, something weird. It's not really correct. Okay, something is wrong. It is kind of using some angles, but not in the way that I want. So let's see what's wrong here. Maybe these calculation might be wrong. Maybe. Okay, let's see. I want to make sure that if this is a angle, this angle is correct or not. So this is value in between 0 to 360. If it's, let's say if it's 90 degrees, this is divided by 45 and you get 2. And if you calculate the remains by 8, you just get 2. If you multiply by 90, then yeah, obviously it should be combined into a pi. I mean radians. So maybe this part is the problem. Okay. Okay, what's the... Okay, instead of using this, maybe this part, this condition might not be good. So, let's see. Or let me just try changing this value into a more simple one. Instead of using 0 to 360, I'm going to use a value in between 0 to 8 as an integer, which will be more simple. Okay, just to check. So the angle is angle multiplied by 45 degrees divided by 180 degrees divided by pi. Oops. Oh, wait a minute. It has to be multiplication instead of division. That's what's wrong. Okay, my mistake. This has to be division, this has to be multiplication. Okay. Okay, so this should be fine. Let's go. 0, 45, 90, okay. 135, 21, 24, 5, 375, and 320, 360. Okay, looks good. Okay, so the angle now works, I think. Yeah, and what else? Now after I mean this is pretty much done with the sorting effect. What you could do more is to deal with the masking part, which you have it here. This is currently fine in some sense, but in order to have more like randomish bars appearing, like you do have already some randoming bars here and there, but let's say I want to add some more randomness to these bars. To do that, you could just modify the mask itself. Inside a COP network, you have these value here. What you could do as an additional stuff for this mask, you could add, like, if it's going horizontal pixel sorting, then you could add some random horizontal noise value to this image to be used for a threshold inside OpenCL. Let's just try that, shall we? And I think I'll just end this live. So based on the angle that I have here, I would like to create some directional noise pattern or noise random pattern. Could be noise or could be random. And to do that, I am going to refer to some of the functions available for Houdini, which is well explained here on the website called Understanding Spaces and Copernicus by the vfxmentor.com. It's a great website to have a lot of reference on the Copernicus, how you can use with the OpenCL. And the one that I want to use is the functions for a random or noise. I would like to use randomness. Okay. So based on the direction informations, I would like to create a randomness, random bars, and add it to a mask image. I could use either one of them. Let's just use the simplest one, xRandom 1, 1. So from one input you can get one float random value. And to use this, I need to import this headers beforehand. So add this import random.h, and not here, sorry, not right here, but what I want to do is to modify, what I want to do is to create a image, the random bar image. So let's just create a constant and create a random bar using additional OpenCL. This will be pretty simple. So what I need is a random functions imported. Also I need an angle information, just like I have in a this pixel sorting OpenCL. I'm gonna go into bindings and copy the angle value, the expression. Just use the same value here. Okay, and also copy the, why am I getting error here? Okay, and copy the angle calculation part. Where is that? Not here. This one. So I'm gonna copy these values as well. I'm gonna use dx and dy as an information to define the random value. This defines the direction of the direction of the pixel sorting, and I'm going to use that as a seed information for the randomness. Okay, so I'm gonna copy it somewhere around here. Let's bind the angle. Okay, and I just need to output as a float value, so I'm gonna specify the output as float. Okay. Now, let's go back to a sketch and let's see what do I want to do. Now, what I want to do is to create in the canvas. I want to, if the direction is going this way as a pixel sorting, then what I want to do is to have some random bars with different colors in this directions, like these. If the direction is vertical, then I want to have random colored bars in vertical directions. And to do that, you need to set the seed informations for each bars based on the perpendicular direction of this original direction, and using the perpendicular directions to calculate in which position this point can be projected on. Meaning you can just calculate the dot product between the perpendicular directions and the point position on each pixels. And you should be able to get the projected point informations, calculating the distance from maybe 0. And that could be used as a seed to create these like orientation direction based value. Okay, so let's do that. So we do have an angle, we do have a directions, but what we want to do is to rotate this into the by 90 degrees to get the perpendicular directions. So let's rotate it, and I'm just going to write up a simple functions to do that just by referring to what I wrote before. You could just search for how to rotate vector 2 or float 2. Yeah, there's a bunch of blogs showing you how to do that. I'm just gonna write one of those functions here. So calculate the cosine and sine with the angle first. Then the rotated value of the vector 2 or float 2 in this case will be cosine value multiplied by b dot x minus s multiplied by b dot y. That's the x, and s multiplied by b dot x plus c multiplied by b dot y. So this is the result of the rotation into the by this angle. Okay, and I'm going to then rotate dx and dy. dx dy to a perpendicular direction, so that will be pi multiplied by 0.5. Okay, so this is going to be the perpendicular directions. Now what I want to have is the dot product between the current point position of the pixels and this perpendicular direction to get the lengths, like the projected lengths, or yeah, projected lengths. So I'm gonna call this L using dot product between the perpendicular directions, and since I'm just going to use it as a seed for the randomness, I don't really need to normalize it. It's not necessary. And the current point position is it's could be, this is just an ID, but you could just use it. Okay. So this will be the length, and this L value, the seed value, is all the same on the directions that I have set. If it's 45 degrees for the 45 angle, or the 45 for the 45 degrees directions, within these lines, every seed value is going to be the same value. So you're going to have a line-like value when you use randomness with this as a seed, hopefully. So let's try to use this as a seed for this vex random 1 1. So vex random 1 1, I'm gonna just enter L, and as a result get some random value. And let's try adding it to a color. And there you go. If the angle is equal to 0, okay, there seems to be some offset here. That is because I haven't wait a minute, why is it? Let me try changing this value and see what's okay. So when it's 0, something, is this because of the resolutions, or maybe something might be wrong here? Not sure why this is happening. Maybe I should make sure to that the value will be integer, so that you can ignore some of the small float errors. That might be the reason. So let's try changing this to an integer to see what would happen. Okay, nothing happens. Funny. What if I just enter like single value? Okay. Assumable. Yeah. Okay. Okay, so these are fine. These looks fine. What if I do X? Okay, these also looks fine. Y. Okay, this is also looks fine. Huh. Now, if I enter L, there seems to be some offset and some locations, which is not sure why it's happening. Maybe I might want to try normalizing this after all. Let's see how I can normalize the vectors or float. do I normalize the float to, or maybe I can just first of all, dx and dy is already not normalized, so maybe I should start from that. Okay, and the dx should be or this one should be divided by dx multiplied by dx plus dy multiplied by dy. Do we have a square root? Okay, square root. And why am I getting error here? Float values, you cannot divide with an expression compatible. Okay. So if you cannot divide by like this, then I'm just gonna calculate the lengths first, then divide it here. Okay, nope. Huh. dx. Why am I getting error here? Private float with an expression incompatible type float to vector 2 vector 2 floor. Huh. Float. Not sure why am I. What happens if I do like this? Huh. Still. Okay, so this has to be float 2. Forgot to do that. Oops. Then maybe I can just divide it by lengths. Okay. But still, okay, and I wanna rotate this by. Okay, well, doesn't really seems to change. I'm not sure if this is due to a resolutions or anything. Let's see. Change the default resolutions. Nope. I think it's some float errors that I have. Okay, that's weird. It's weird. Because in this case, if the angle is 0, then cosine is equal to 1, sine is equal to 0, so this will be 1, 0, probably. So if I say float 2, 1, 0, should be the same. And I'm getting error here. That is because I have to have a parenthesis. Okay, so I'm still having, so problem is with this dot product, possibly. Huh. Okay. Well, then instead of using integers, what about combining into an ID? See what happens. Huh. Disappeared. How is that? Might need to convert it into float. Not sure what's happening here. Wait a minute. So this is Okay, instead of using rotated version, maybe the rotation itself might be wrong. So what about these? Nope. Okay, so maybe something is wrong here. XRAS, IX. What about multiplying it by 100? Okay, well, start. So the value was too small in this case, I guess. In this case, maybe then I can just say IX and IY after all. Float 2. Okay, so this is working. And if I say 1 and 0 and 1, this is also working. But then if I insert the perpendicular value, okay, so maybe the rotation is wrong, obviously. Okay, gotta see what's wrong. Let's check what I have written here. C multiply by, okay, I'm just gonna copy paste the one that I wrote beforehand, compare with these. Looks pretty much the same. Just okay, let's delete it and test with this one. Nope, it's not changing. Huh. Maybe the chances that this rotation, the pi value, the precisions of this pi is not good enough, which makes some errors here. That's my guess. So let's see if I can, well, it's already pretty high, so maybe not okay, well, another chance is making this perpendicular value larger. Nope, or smaller. Yeah, it's getting worse. Huh. Why did it work last time? Let me just check what I did. Well, I'm doing exactly the same thing. Do I need to make it F? And now it's what? Okay, here. Not really sure what's happening here. Yeah, I'm trying to create a barcode like value, but this small error here probably happened by this things here. It's kind of killing me. No, still the same. I make this 45 degrees. So 45 degrees looks fine. Yeah. 135 also looks fine. 90 degrees. No. When it comes to perpendicular directions, it's not working somehow. 100 degrees? What about just rotating by 0? Huh. Wait a minute. This is not correct. This is not correct. So if it's 0, that's fine, but if you multiply pi by 0, oh, still fine, still not. If you multiply by pi divided by 180 degrees. 90 degrees. No. Okay. So the pi itself has an error here, like this. So I am going to avoid using pi, but instead I'm going to look for a precise pi value. How do I get that? Constant value for the pi. Okay, something like this. Let's try using this instead. It didn't happen last time when I tried, so I'm not sure what's wrong here. Ooh, nope, still not correct. I don't know. I don't know what's happening here. Maybe it's not the pi, but it's cosine and sine. That's what might be wrong. Yeah, so this is fine. Should I go with the lower numbers? Wait a minute, what? Shit. So higher precision number gives you an error, but if you go with the lower numbers, seems like it gives you a better result. Not yet. Huh. Okay, not sure why. Maybe this has rounded up the result of the cosine and sine. That might be the reason. Okay. Okay. Fixed. Well, anyway, I mean, the yeah, this is the result that I wanted, but not sure why this happened. Okay. Well, anyway, sorry for taking this a bit long time to solve this, and thank you Alan for tips. It worked, and I am not sure why. Maybe it was too precise. The pi was too precise. Okay, then I have an angle also. So if you have vertical lines like this, no, actually I want to rotate by 90 degrees, so I have to multiply by 0.5. So if you have a horizontal directions, the pixel sorting also happens in horizontal directions. Now what I'm going to do next is to combine these two together, and possibly using something like add node. So something like this. Now obviously currently the random bar is too strong, so it's affecting a lot. So let's also try to reduce the amount of randomness by multiplying the final randomness by some multiplier. I'm gonna call this random mult. As a float, let's say 0.3. So maximum 0.3 will be added to a original mask. Let's also bind this, which is not necessary, but will be easier to see what kind of values we have here. What was the name? Okay, so right now some randomness with the horizontal directions being added to the mask, and let's see what would happen with these mask applied, updated mask to this image. Okay, so some more random like bars being added to the scene. So a lot of places has been used for candidate to be pixel sorted. Beforehand, the mountain side, forest side wasn't a candidate for the randomness, but by adding some randomness to it, the original mask, it's being added a candidate, so you're going to have more random things happening here. If you can change the angles to 90 degrees, you're going to have more like sorting happens. And having additional randomness as to a vertical directions, you are going to see some more pixelized effect. And you could reduce it to something like 0.1 to have less effect. Let's see. So with this, a less effect and a bit more interesting result. Okay, so these are kind of a additional touch to what we have for a pixel sort functions. Let's also try with the diagonal directions. Yeah, this could be interesting. Okay, so we do have a little number of parameters, so let's gather all those parameters into one little node so that we can control outside the solver. So one is the brightness threshold, like these. Let's copy that to a controller. Let's open up the parameter interface. Change the brightness. Let's change the name to mask. Mask brightness. Okay. The other one. Let's go inside a solver. Inside the CopNet. So we have frame is automatically decided, substep is automatically decided, threshold value. This is with the mask. So okay, and the angle is, or we already have it, so that's fine. Okay, for the randomness, the mask random multiplier to a moving directions, which should be in between 0 to 1. 1 means every pixel's gonna be more likely candidate for pixel sorting. So okay, so and you might also want to choose your files, the image file, which is defined here. Okay, so I could also bring this right here. Okay, that's pretty much it, I think. Now I haven't fixed the margin part yet. I don't know how I can actually fix it though. I was hoping this will fix it, but it didn't. This is LGBA4 by resampling it. No, I don't want to scale it like this. Stretch to fit. Okay. Oh, this looks fine. Okay, fit horizontally. Looks like the way to go. Okay, looks fine. Fit vertically? Maybe not. Okay, so let's try. Okay, looks good. Now, going back to the parameters, and let's see what can we do. Let's try changing with the different images, like this bone skull of the animal. Okay, starting with the 90 degrees. You could actually change the angle in real time, I mean during the solver, which could give you some interesting effect, and you could also increase the multiplier or the randomness. In this case you have a bunch of black areas, so it's okay to, I guess, increase some multiplier, more than 0.5. Kind of a sketching with kind of sketching tool. Okay, looks good. Let's try with the other image. Okay. What's going on with the... Okay, in this case, if this is vertically long image, so in those cases I think I need to make the tiling to fit vertically. So probably I want to decide this parameter automatically. How do we do that? Can we have an expression? Horizontal. So this is horizontal, and this is vertical. Okay, so seems like we could write some expressions here. Now, what I want to get is the size informations of the original image here, data window. Not sure how I can get this info from a channel. I'm not sure. Size ref. There should be some expression to check the info, like this size. Not sure how to access that. Maybe we could check that. Expression functions for Houdini. Hopefully we can get Well, this is not a channel-based value, so I'm not sure how am I able to access those. Returns numeric metadata from my compositing node. Maybe this one. Cop meta. Why do we have two? So a compositing node, metadata, name, index. Okay. Metadata can be added as a sequence with a metadata cop. Well, first of all, I'm not sure if that's exact, if that is a metadata that I want to access, but let's try. Let's just try with the simple new node, adding some value here and see if I can get that information using the expression cop meta. So the name is file1 and the metadata name is data window. I'm not sure if this is a metadata. What's the name? Data window. Zero. Do we get it? No. Data window. Nope. Not sure. Maybe this could be string. Just checking. Let me know if and I don't have an idea how to convert it into a number, even if it's a string. There must be a way to get better. I mean, I just want to get the width and height. That's all in the expression. So if I can get it somewhere, maybe as a channel or something else, it's better. Analysis. Let's go back to a expression, see if I can have different function. Stamp, nope. It's not really related to cop. So we only have these. Test if metadata. Okay. I don't know. I am not sure. I don't know, maybe if I have copy methods like this, then if there's a function to split the string separators component, I could split the string by x. Is this meta correct? Seems this one's correct. And if I have a split function, what is the component? Yeah. So and hopefully we're getting the first value, and then I want to convert it into an integer, and maybe then I could check it here. Nope, maybe it's not working. Data window, just want to check if this is working. Nope, so this itself is not working. Huh. Huh. How do I... Oh. What? I don't need these? Okay. Nope. Just not sure if I'm... maybe not. Maybe I am not getting a value, the one that I want here. Well, that's a minor thing. That's just a minor thing. So these are the meta one. Maybe these are not the metadata. Not sure. Wait a minute. Maybe without these? Wait, no. It doesn't even give you an error, so I'm not sure if I'm doing wrong or not. Oh. Oh well. Anyway. Yeah. Doesn't matter. Doesn't matter. Thank you, Alan. So the cop meta is for the old cop system. Okay, so it's not gonna work with the new one. Okay, then I'll just gonna be maybe I'll just put this in a parameter and that's it. Well, I believe there's a way somewhere, but I'll just look for it sometime later. Should be a way. Just gonna bring this parameters on here. That will do the job. It's not automatic, but better than nothing. Better than nothing. Okay. Alright, so with these, okay, looks interesting. If I make this 90 degrees and seems like most of the parts being chosen for a candidate for pixel sorting, so maybe I should decrease the brightness. A little bit more. Let's try with 0. Okay, so you start to see only these parts being dissolving. It's interesting. It looks like melting. Okay, or anyway, it works with a metadata cop, which does not exist in Copernicus. Okay, thank you. Good to know. Alright, so that's pretty much it. Wait a minute, I have to turn this on. I was wondering why it was so slow. Okay. Alright, so this is pretty much it. Let me know if you guys have any questions with the one that I have here. Will be great to know. Let me know how you thought about the process. How I showed you today. The algorithm itself is pretty simple, the sorting part, but the result is pretty. I found it pretty interesting. So hopefully you liked it as well. Okay, let's also have some informations to set the resolutions, the base resolutions. Let's set the maximum to 248, and so that I can control the resolutions by myself. Okay. Oops. Okay. And let's try with the other one. I've already tried this. The orange. Okay, 135. Oh, just this part. See, kind of interesting to just move around during the animation. Okay, anyway, that's it. Thank you very much for watching, and all those feedbacks and comments. Thank you. I'll finish this live here. So as always, I'm going to upload the files that I've created during the live stream and paste the link to a video description page of this YouTube video so that you can download and play out with it. Yeah, you can come back to this video later to download the file. There's also a Patreon page, so if you are willing to donate, that will be awesome as well to support me. Okay, that's it for today. See you next week with something different again. Alright, that's it. Good night, and hope you have a good weekend. Just gonna play out with it a little bit more, and I'll finish this live. like it. Okay, night, and see you.